Good morning once again, participants. It's time to introduce our resource person of the session 2 for today, Dr. K. Mahalakshmi. She has over 22 years of work experience in both teaching and software development. In that, she has over 5 years of software industry and the remaining 17 years in teaching. She has completed her PhD in the Faculty of Information and Communication Engineering from Anna University, Chennai. And she has her master's in Master of Technology in IT from deemed University Allahabad. She has done her MBA in HR from Annamalai University from 1999 to 2001. And currently she is working as a Dean Center for Industry Institute Interactions and Professor CSE in Kalaignarkarunanithi Institute of Technology, Coimbatore from May 20 till date. And she worked in other colleges also in Karpagam College of Engineering Autonomous Coimbatore from May 2015 to May 2020. And she worked as an associate professor in School of Engineering and Technology, Surya Group of Institutions, Vilupuram from April 20 to May 2015. She has carried various responsibilities in Surya Group of Institutions as academic coordinator, head for placement and training, and head of the department CSE. And her area of interest includes software engineering, in that specialization in requirement engineering, big data analytics and data mining, cybersecurity. And she has special skills like career counseling. She's a motivator. She's a soft skill trainer, and she has over 34 international journals in her name. International conference she has 8, and she has a lot list of publications. And she has done so many workshops and trainings. Good morning, ladies and gentlemen. We have in our midst a very great academician, and she is going to give a lecture today. We welcome you, ATAL team welcome you on behalf of CIII Engineering College, Department of Computer Science and Engineering. Thank you, ma'am. You can proceed. Over to you, ma'am.
Good morning, sir. Good morning, sir. Thank you for your warm welcome. It was nice, and thank you for the opportunity to meet a variety of people and discuss on a particular topic. Nothing much like it's just sharing of collective information which I have gathered on the blockchain with IoT. Let me share my screen. Hope my screen is visible.
Yes, madam, your screen is visible and your voice is clear.
Yeah, you, all of you should bear with me. I have a very bad throat and I'm a bit sick, but somehow
very sorry, madam. Very sorry.
No
issues.
Do not feel sorry. It's really an opportunity, so you should bear with my throat.
Yeah, sure.
Just to stick on to the schedules, I just wanted to. So the topic that I have been given is blockchain for IoT security aspect. Actually, blockchain is basically a technology where we talk more on security part. So how does we IoT security challenges are going to be sorted out by blockchain? While getting into blockchain, let us have an overview of blockchain is about. Blockchain is a shared ledger, okay? It's just a ledger, a collection of ledger that is able to facilitate the processing of recording the transactions and tracking the assets in a business network. So when we say it is an asset, can also be tangible, like a house, car, cash, land, or even intangible like intellectual property, patents, branding, copyright. So virtually anything of value can be tracked and traded on blockchain network and reducing risk and cutting cost. So that is what they talk about security, and that is reducing risk is security and cutting the cost. When we look that a business is running on information, so the faster it receives and the more accurate it is, the better it is. So blockchain is ideally for delivering that information because it provides immediate, shared and completely transparent information stored on ledgers that can be accessed only by permissioned network with authenticated network members. So a blockchain network can track orders, payments, production, accounts and much more. So when we say that members share a single view of the truth, that is whatever may be the network, they share a single view. You can see all the details of the transaction end to end, which is giving greater confidence with new efficiencies and opportunities. So that is the, when we look into the elements of blockchain, the first thing that comes is distributed ledger technology. So what we mean that is all the network participants have access to the distributed ledger and it is immutably recording the transaction with its shared ledger. These transactions are recorded only once, eliminating duplication of effort, and typically it is of traditional business network. When we say records are immutable, no, that means the participants cannot change or tamper after the transaction has happened or the record has been recorded in the shared ledger. If a transaction record includes an error, a new transaction must be added to reverse the error and both the transactions are visible. There is nothing like update. We have, if an error is being updated onto the blockchain ledger, the another transaction has to happen to reverse the error. So both will be notified, seen, that is transparent. Having next element could be like smart contracts. So to speed the transaction, we have set of rules that is called smart contract that is stored on the blockchain and executed automatically like constraints on a database. A smart contract can define conditions for corporate bond transfers, which is could include in terms of travel insurance to be paid on a particular transaction like that. So that is like a constraint on a database. So we are having smart contracts. So next, what could be the benefit? What we need to change? See, the operation often is the effort that is taken for duplicate record keeping and third party validations. Because what if an error happens, we have to reverse the error by adding a record which will be transparent. Both the error and the reversal of the error in a blockchain. So what we have to do is the waste effort on duplicate record keeping and the third party validations, the contracts we have to keep. So the record keeping systems can be vulnerable to fraud and cyber attacks. So we have limited transparency that can slow up verification. And with that, the arrival of IoT, the transaction volumes have exploded. So all this slows business and it also drains the bottom line, and which means there is a better way to enter blockchain. So we go for blockchain into IoT, which is giving greater trust. With blockchain as a member of members only network, we can rest assured that we are receiving accurate and timely data in our IoT, and our blockchain is confidential, that records will be shared only with network members to whom you have specifically granted access, authenticated to whoever has been authenticated. And it also has greater security. The consciousness on data accuracy is required from all network members, and all validated transactions are immutable, permanently recorded. No one, not even the system administrator, can delete a transaction. So no tampering of record could happen. So this gives more efficiencies. With a distributed ledger, this is shared among the members of the network. Time-wasting record reconciliations are eliminated, to keeping the records in consistencies. And to speed the transaction, a set of rules called a smart contract can be stored on the blockchain and executed automatically when the record has to be updated on the blockchain. Example would be like insurance. Whenever we book a railway ticket, the insurance part of it comes there. So those things could be taken as smart contracts. So when we just look into, we're not going to go deeply into blockchain works, or just an overview of how the blockchain works. So when we see each transaction occurs, it is being recorded as a block of data. Those transactions show the movement of an asset that can be tangible or intangible. Tangible means the product, the intangible asset is the intellectual. The data block can record the information of the given choice. Who, what, where it is, how much is required. All the information, we can have it as a choice. We can even have it as a temperature of the food shipment. If you are going to use blockchain and IoT for the shipment of pharmaceuticals, there even we can capture the temperature of the food or the medicine that is being shipped. So we have it as each block is connected to the ones before and after it. This block forms a chain of data. So there comes the name as blockchain. As the asset moves from one place to another, so the ownership also changes hands when the block moves. The block confirms the exact time and sequence of transaction, that the blocks links security together, preventing any blocks being altered. So they've been securely linked together, preventing any block from being altered or the block being inserted between the existing blocks. So that cannot happen. It has to happen in sequential. So the transactions are blocked together in an irreversible chain that is called blockchain. So each additional block will be strengthening the verification of the previous block, and hence the entire blockchain becomes non-vulnerable. So whenever you have an addition of each block, that is having a verification to the previous block. So this is rendering the blockchain as a tamper evident. Tamper evident is a tag given. So the blockchain, if it's going to be even tried tampering, that has become evident, it is shown or recorded. Even those attempts to tamper is being recorded, delivering the key strength of immutability. So this removes the possibility of tampering by a malicious actor, and it is building a ledger of transactions, and you are having network members where you can trust. So in short, when as a summary we take it up, so blockchain is a database. Okay, it's a kind of database that is shared across a network of computers. Once a record has been added to the chain, it is very difficult to change. So you ensure all the copies of database are the same on the network, because it's shared on the network. All the copies on the network nodes are checked for consistencies. Blockchains have been used to underpin cyber currencies like Bitcoin, but many other possible uses are now emerging. It is not only for Bitcoins, major are being emerging. So as a database, the records are bundled together. How does it look? This is how the look and feel of a record, the block, and the entire chain. The records have been bundled together into blocks and added to the chain one after the other. So these are the basic parts of the database. The record, that is just an information. Okay. So there is a trade is being recorded, for example. So the coins, Bitcoins shared will be the record listed. So that's the ownership change also, you will have the tag. So the record, this is a full blue one, is a block. The block is attached to the chain. Excuse me. So coming to IoT and blockchain, how does you have blockchain technology utilizing? So IoT is mainly a centralized access. Now moving that IoT to a distributed ledger is what blockchain is going to give you. Now we're going to try to define the IoT applications by distributions. It is only normal that a distributed ledger technology, which a blockchain will play a role, and how devices will communicate directly between each other. That is, keeping a ledger and the trail of just devices, now they start to interact, and potentially there are how they are handled in case of tagged goods. So the blockchain is designed as a basis for applications that involve transactions and interactions. So these can include the smart contracts, which are a specific conditions on smart applications that support specific Internet of Things IoT processes. This way, the blockchain technology can improve not just the compliance of the IoT but also the IoT features and cost efficiency. The industry is not just waiting, it starts taking initiatives for having blockchain incorporated into cognitive IoT. In fact, it is a combination of artificial intelligence also into IoT and blockchain as a threesome will prove much interesting across industries, industrial IoT applications. With blockchain, it is very much pretty adding to the changing digital infrastructure that powers many evolution in many areas like analytics, from analytics to security in an environment which is so far was centralized. So far IoT was centralized, try to make it decentralized. IBM has taken a lead role for incorporating the blockchain. As I said, the industry is not wading into IoT. They are often mentioned as blockchain benefits with the parts of infographic and IBM in-depth information. So the three benefits as using blockchain for IoT according to IBM that they have come up with is building trust, cost reduction and acceleration of transaction. The IoT and blockchain challenges are still needs to be solved. So the technology which mainly security comes in the picture in IoT context where IoT security is already a challenge. It is clear that security needs to be even more looked at. It is important to note excuse me, just 1 minute. Actually, IoT security is already a challenge. So with this, it is important to note that the blockchain has also seen a way to secure the IoT, and as already said, the security is the overall, but it is another options and aspects too. So you have operational challenges when, because totally IoT and blockchain is operating in centralized and decentralized ledgers, trying to merge the two extreme poles we can say. So we come up with operational challenges. What happens to the underlying business model, the IoT and the blockchain? So the business model with the practical aspects may require a lot of agreements, of course, like actor based on ecosystem, how we are having the access given, because given to the IoT environment and the blockchain environment has to be done with the business model agreements and requirement discussions. So then getting on to legal issues, compliance issues. So that also has to be taken as the responsible issues to be taken by the devices that's connected to the IoT. So it's based on the rule that automatically you're going to get executed by a blockchain based application, which is going to trigger by another blockchain based applications. So the complexity increases when you're adding blockchain to IoT. And as mentioned as an example of smart contracts, so these must be even outside the context of IoT. So this is where we say the blockchain is a game changer for IoT. So to answer all the challenges of IoT, they are trying to get in our blockchain. The blockchain technology is also trying to promise to be the missing link enabling the power-to-power peer-to-peer contractual behavior of a IoT transaction when it's going to be a third-party transaction. So it is trying to answer the challenge of scalability. Okay. As a single point of failure, we have to have timestamping. We need to record the privacy, trust, and reliability. So the blockchain technology could provide a simple infrastructure for two devices to directly transfer a piece of property such as a money or a data between one another, which are secured and reliable. That's more important. Reliable time-stamped handshake. That is, when we are enabling message exchanges, IoT devices needs to leverage smart contracts with a model agreement between two parties. This feature is enabling the autonomous functions of smart devices without the need for centralized authority. So, that centralized authority of the smart devices, IoT devices, are taken care by leveraging smart contracts that's being done of blockchain. So if there is to extend this transaction, that is a peer-to-peer transaction, to human or human to objects, so we end up with a fully distributed, trustworthy digital infrastructure. We can try to come up with that. So the example, the example that we can quote with blockchain plus IoT across industry is can take insurance as an example. Okay. So the main use case of blockchain in IoT is taken as insurance, which is forcing on smart contracts and the enhancement of several processes which claim management, is happening in insurance. So blockchain is thoroughly now looked at the legal sector as well. So we cannot tamper proof any transaction that's happening. So even the technologies in the insurance contract is getting into legal sector. So In the scope of blockchain and IoT, it is interesting to look at this combination. Since IoT claims that it is tamper proof, we are using it, started to use in many industries. Beyond having any telematic models, which are the connection of real-time IoT data. So the various perspectives for various intelligent automated insurance policy applications. So that's why we want automated insurance policies. So sometimes this may even look very future applications of blockchain. Noting that from an IoT investment perspective, before 2 years, this insurance would be among the fastest growing industries. It may go on up to 2021 maybe. So this can also be made use for connected cars, smart cars, and the insurance connected as a blockchain with the smart contracts applied on it. So we'll start reimagining the world's most fundamental business interactions and try to open the door for inventing new styles of digital interactions with a reduced cost and complexity of operating and sustaining the businesses. In the broader picture, IoT and blockchain is also for manufacturing and security to ERP and autonomous decisions. So, okay. In the context of technologies, in the broader sense, we can think of a convergence of IT and OT, that is operational technologies and manufacturing technologies with the standards of protocols are now revolving around data capturing, making interoperability, analyzing and leveraging for data exchange and blockchain constantly that's happening up. It is whereby the automated interaction can be seen as a contract in a non-legal sense, but in the sense of a condition-based, it is an automated policy that is being taken. In this context, we need to mention here about Industry 4.0 and its end-to-end data approach, and of course, this evolution in logistics systems like Oracle Transport Management, all incorporating the blockchain aspects for the IoT. Taking into consideration the Industrial 4.0, the smart logistics that has been focused on the end-to-end data model, but also on autonomous decisions taken. So, as in case below, it indicates that there are ample opportunities in a far less complex context. So again, we need to mention here IoT and blockchain are for next generation security, and it cannot just even cover cyber security with its security challenges. Giving an example of plant floor is in a manufacturing center or in a industrial environment level, whereas critical infrastructure is increasingly
Ma'am?
attractive.
Ma'am?
bad guys,
Ma'am,
called securities.
ma'am, Maha ma'am.
Yes,
Ma'am, this is Guru from CIII Engineering College.
yes, sir.
Ma'am, is it possible for you to continue like this?
Yes, sir. I'll go on.
Okay, sir. Okay,
No,
ma'am. No problem. Even if it's possible for you to go till 12:30 also, it's fine. And then
yes, sir.
also we can close the session. No
Sure,
issue.
sir. Sure, sir. I'll make it as.
Yeah,
Thank you for your concern.
no
I really
problem,
like. I
madam.
was
Take
looking
care, madam.
forward for this.
Take care. Have plenty of water, ma'am.
Yeah, yeah. I'm having it, sir.
Yeah.
Thank
Thank
you
you,
very
madam.
much.
Thank
I'll
you,
go
madam.
on.
Thank you.
So we were talking about machinery. Okay, the industrial part of it. Okay, so that is with the. Okay, I lost. It is with the bad guys. I was talking about cyber security. That's attracting. So adding robots now. So robots is with IoT in a manufacturing environment. So what happens? Adding robots, adding systems, having ERP, that is our IoT. We take ERP. So according to this, adding a blockchain, cognitive computing are the three pillars for next generation of ERP, known as intelligence ERP. So the list goes on. Okay, the same way we can say IoT blockchain for smart buildings to the energy industries, smart buildings. What so so that keeps on adding, just like our industrial IoT and blockchain, we say with smart buildings. So if the case series goes on, I have challenges and issues of IoT so that we'll be able to list out how it is being could be addressed by blockchain. So though IoT is having several benefits, right? We cannot say it's only having issues. Several benefits are there, and we're able to solve a wide range of problems in various sectors. Still, the challenges exist. So these challenges might be we could overcome in the security issues, privacy concerns. So the challenges of IoT in this design practices. So design practices we will say is the lack of resources in to train future generations about secured IoT device. So that will be the design practices we will take off. Then we look into cost versus security trade-offs. There is a lack of information decisions over cost benefit analysis of IoT. When we talk about standards and metrics, we need to, there's a lack of standards to identify the security in IoT devices. Then, confidentiality, lack of optimally controlled role in IoT device communication models. So to prevent the threat of hijacking, cyber security attacks. Field has been upgradability. We talk about no sufficient information on maintainability and upgradability issues. So this has been based on the expected lifespan of IoT devices in a network. So we talk about shared responsibilities. We also ask a question, could IoT security be achieved without shared collaborations? We need to have a rethink about that point. So talking to regulations, the IoT device or software developing without the security laws, we need to take the legal activities. When the device become obsolete, we are having limited implementations on replacing the older and the undesirable devices. Okay, so taking the primary concerns, that is lack of strict rules against data collection and usage. We need to have data collections, privacy, then having lack of third party models, that is which is enabling transparency, expressions, and having the enforcements. Then also privacy protection models for IoT, okay, and inability to recognize this privacy expectations of users. So we are having wide range of privacy expectations. Then privacy by design, we have limited resources to develop IoT devices integrating with trained principles for privacy, having an identification for protection against data collected by IoT devices. Next would be the interoperability that we need to think with IoT devices. The proprietary ecosystems, that is lack of closed ecosystem concepts in data collection format and how we reuse them as per user's choice, that is customer's wish. So we need to have individual security keys and protocols to be implemented. Then the limitation forced on the technical and cost constraints for technical resources and investments has to be taken. Scheduled risk, chance of outpacing the interoperability standards. We expect the interoperability standards outpacing. What happens when the IoT connected devices is outpacing it? Then the less the awareness over the technical design risk protocols, technical rigor, and the behavior documented standards for best design practices for designs behaving badly, looking into the design principles, the practices, then taking the standard legal systems for maintaining IoT device and configuration, having lack of standard configurations. I mean, when we go for larger number of IoT devices, when we take off the configurations, the standard issues are less effort in developing standards and protocol, less developments in data sharing and trust policies, then having lack of laws, discriminations using IoT data, lack of laws for IoT data for sharing to fight against the crime. And we have law enforcements, then law against liability issues when we have a transaction. Then the device having the consideration of complex liability during IoT device operation, having limited investments in IoT research and development activities, then going into infrastructure resources, maybe more of a burden or a pressure on internet and the communication infrastructure across the globe when we take as infrastructure resources, having activities in strengthening the internet and communication infrastructure. A study has to be evaluated for technical and economical benefits of IoT in emerging economic countries, having the awareness on the policies and plans with the continuous growth for IoT coordination. So this is our IoT components interactions, how that is with things Excuse me 1 minute. This picture is showing the schematic interaction that is happening in the IoT devices. From the interaction point of view, data will start flowing from data collection unit. That is typically some things with networked sensors and actuators to information processing and storage stage. Information processing storage stage could typically be the raw information processing and data storage for reporting the stages. So during this process, there are chances of losing or mishandling could happen to the data, making the data flow process not 100%. So this data must flow through the internet with some protocol, and chances of misleading or misinterrupting the protocols with the help of external influences is highly possible. So for example, we can take it as hackers can control the data process flow. So during the second interaction between the computing engines can be hacked or taken control by external users. So in this case, the chance of analysis interruption exists. The analysis interruption exists. So the third interaction that happens, some feedback could go to some computing algorithms which should be sent according to the things, that is Internet of Things, to act here. So there is a chance of hacking, and negative control over feedback loop is definitely possible in an IoT. So apart from interactions between the three components, we also have individual components also losing data occurs by some wrong protocols. So there is a huge scope for security and privacy concerns in IoT, which will be a serious problem. Then we can ask, could blockchain technology can be a remedy? How it can be? Yes, the blockchain technology could be or would be one of the remedy for addressing the security and privacy issues in IoT. This is because the blockchain technology eliminating the central server concept of IoT and allows the data flow through the blockchain distributed ledger for each transaction with proper authentication. So when we have a look at the data flow, this is how a network in IoT with a centralized network, and this is a network in IoT with blockchain technology. We are having decentralized network and distributed network. The above first part of the image diagram shows the data flow that is happening in IoT from the sensors to the network to the router. It goes the internet and central server and big data, and then goes for analytics, then the user. When blockchain is being introduced, we can eliminate or change, not eliminate, eliminate and change the path from centralized servers to a distributed blockchain. Since blockchain comes with constraints for smart contracts, we can have it directly, and blockchain is another way of storing. So big data is being eliminated, and it directly goes for analytics and users. So we can look for blockchain technology as a solution to IoT security challenges. It can give better solution faced by IoT systems. So in this growing scenarios of IoT systems, there are more chances of having increased number of transactions, that is interactions in things or devices, that is in IoT, more transactions. These increased number of devices will try to interact with each other, making internet as a medium. This would lead to many hurdles in IoT system because the collected data is maintained in central servers. If the devices want to access the data, they have to interact using the centralized network, and the data flow will happen through the centralized server. This process is shown here. But the growing needs of IoT and its applications are portraying IoT as a large-scale system with integration of advanced technologies. In such cases, IoT systems with a centralized server may not be an effective approach. So, most of the IoT systems now relying on centralized data could be converted to distributed blockchain. From the centralized server, analytics are performed, user requirements and convenience. So this is being covered by blockchain. For handling huge processed large-scale IoT systems, there is a need for increasing the internet infrastructure. One best way to solve this is decentralized or distributed, where peer-to-peer networking, PPN, or DFS, distributed file sharing, or autonomous device coordination, ADC, could be capable of. Blockchain can carry out these three functions, allowing the IoT systems to track the huge number of connected and network devices. So the blockchain allows the IoT systems to process transaction between devices and coordination. The BC will enhance the privacy and the reliability of the IoT systems, making it robust. So that the advantage would be tamper-proofed, peer-to-peer possibility being robust. I take a pause here so we can have a view of the slides. So in IoT with the BC, the data flows from sensor network, router, internet, distributed, blockchain, analytical user. That's what we say. Sensor network, router, internet, distributed, blockchain, analytic user. So the distributed ledger is tamper-proof, with which does not allow any misinterpretations or wrong authentications in data. The BC's complexity eliminates the single thread communications, making IoT system more trustable, adopting BC in IoT. Okay. So With this, I have another survey looking into the where all the threats of IoT are. The threats of IoT are. It's just a survey taken, I pulled out. You can see the user practice. Because of user practice, the threats are there. Exploitation happening, malware. So another thing is that before we could conclude blockchain for IoT security as a perfect match, we need to look into the places where in business convenience is prioritized over security. Yes. Compromise of security is happening for profit making. So we need to again relook at the centralized IoT network model, high cost of centralized cloud maintenance, networking equipment, low interoperability due to restricted data exchange with other centralized infrastructures. Having a single gateway, when we say centralized IoT network module, have a single gateway is not trustworthy. It allows gaining access to the whole IoT network by compromising a single device. The blockchain, I have one video here which I don't know whether I'll be able to play it and project it. It talks about one case study with a pharmaceutical company using I may try to copy the link and put it in the chat window. Sorry, it is, I'm not able to open it, the YouTube link. I will. This would give you just a small video on the YouTube to talk about how blockchain could enable security aspects or take care of the security aspects of IoT. And with that, I come to the end of my presentation.
Ma'am, you have done correct?
Yeah, I've done with that.
Okay, madam. Madam, participants can ask queries.
Yeah.
Is that fine, ma'am?
Yes, sir.
Yeah, okay.
We'll try to address.
Yeah, okay, ma'am. Dear participants, you can, this is an open session. You can ask queries to madam or you can put it in the chat box. You can post in the chat box or you can ask the question to ma'am. Ma'am is open to answer.
So many people have put take care. Thank you. Definitely I will take care of it. I took the commitment and I thought I should. It is, I know, like shouldn't overload the organizers. I know in a series of lectures.
Yeah, ma'am.
Someone pulls away. Not disappoint the. I don't know, suddenly for past 3 days I'm having this. I thought one day or the other it will get okay. Much better. At least some voice is coming.
Consulted doctor, ma'am?
Yes, sir. I have consulted. I'm taking on Siddha.
Okay.
Thing. I just had it as a very simple eye-opener session, just a discussion. Like,
Okay.
thank you.
Yeah. Any question?